On this question, we want to use the graph of y equals 2 to the x and the transformations to sketch the equation of the function f of x equals 2 to the x plus 6. We want to determine the domain and range, and also determine the y-intercept and find the equation of the horizontal asymptote. Now the first part says we want to use the coordinates of the points on the graph of y equals 2 to the x. Those coordinates are given to us, but I want to go over where these coordinates come from. So if we have the equation y equals 2 to the x, we can find ordered pairs that are on this graph by plotting points. I can make a chart of x's and y's and choose x values and find the y's that go with those x values. You can choose a standard set of x's, -2, -1, 0, 1, and 2, and substitute those values into the equation to get those y coordinates. So that's 2 to the -2, 2 to the -1, 2 to the 0, 2 to the 1, and 2 to the second power. We simplify these. 2 to the second power is 4, 2 to the first power is 2, 2 to the 0 power is 1, 2 to the -1 power. Having a negative in the exponent means reciprocal of that base. 2 is the base, -1 is the exponent. Having that negative means reciprocal of the base. Reciprocal of 2 is 1/2. We would still raise that to the first power, and 1/2 to the first power is 1/2. 2 to the -2, that negative still means reciprocal of the base. We're going to do the reciprocal of 2 is 1/2. Raise that to the second power, and we get 1/4. So this is our base function. We want to think about the graph of this base function. We can take those ordered pairs and plot them, -2 and 1/4, -1.5, 0, 1, 1, 2, and 2, 4. We get a graph that looks like this. And for later, it's important for us to know that there is a horizontal asymptote that is right on top of the x-axis, and that is the equation y equals 0. And you can see that the ordered pairs that are written down right here, -1, 1/2, match the ordered pairs that we figured out for ourselves, 0, 1, 1, 2. So these are ordered pairs that are on the graph of y equals 2 to the x. We want to find the corresponding points that match for this other equation, f of x equals 2 to the x plus 6. So we now want to know ordered pairs that are on the graph of f of x equals 2 to the x plus 6. We're going to use our knowledge about transformations. So the difference between our base equation, 2 to the x, and the function we're interested in, 2 to the x plus 6, is this plus 6 here. So we need to know what that transformation does to the graph. We know that when we have adding or subtracting, that creates a shift. And so we have adding 6, that's going to be a shift. Because that adding is inside of my base function, I know it is a horizontal shift. And because it's a plus, I know it's a shift left. And we're going to shift left 6 units. So if we take the ordered pairs here and shift those ordered pairs left 6 units, we'll arrive at the ordered pairs that are on our graph f of x equals 2 to the x plus 6. So let's take these points one at a time. The ordered pair -1 and 1/2, if I want to shift it left, you may have a hard time thinking of this in your head. So it might be helpful if you use your graph that we made earlier. So we have this point right here, which is -1 and 1/2. And we want to shift that left 6. If we shift that left 6, that means that we're going to arrive 1, 2, 3, 4, 5, 6 right here. And if we think about that ordered pair, you'll notice that the y-coordinate did not change, only the x-coordinate. So the x-coordinate, we moved it 6, we subtracted 6 from it, and that gets me to an ordered pair of -7 1/2. We can do the same thing with the next coordinate of 0, 1. The y-coordinate will stay fixed. The x-coordinate gets shifted left 6. And we have the ordered pair -6, 1. If you have trouble doing this in your head, use the picture of the graph to help you. And then we have 1, 2. The y-coordinate will stay the same, and the x-coordinate, we subtract 6. It's a -5, -2. So we have our ordered pairs that are on the graph of 2 to the x plus 6. Let's answer the remaining questions. We want to determine the domain and range. In order to determine the domain and range, I'm going to plot these points so I know what that graph looks like. 1, 2, 3, 4, 5, 6, 7, and 1/2, -6, and 1, -5, and 2. We get a graph that looks like this. So for our domain, the domain is going to go from -infinity to infinity. So this portion of the graph, even though it keeps getting larger and larger, it also keeps moving to the right. And so it's going to cover every x value. The range, because of the asymptote, the range is going to start at 0, but 0 is not included. The graph never actually reaches the asymptote, it just keeps moving closer and closer. We want to determine the y-intercept. So to find a y-intercept, we're going to let x equal 0 for our function f of x equals 2 to the x plus 6. I'll substitute a 0 in for x, and that gives me 2 to the 0 plus 6. That's 2 to the 6th power, and 2 to the 6th power is equal to 64. So the ordered pair 0, 64 is the y-intercept. We also want to find the equation of the horizontal asymptote. I mentioned the horizontal asymptote earlier when we were graphing the base function. And remember the transformation that we made was to shift left 6 units. If we think about shifting the horizontal asymptote left 6 units, the horizontal asymptote still remains on top of the x-axis, which is y equals 0. So we have our horizontal asymptote being the equation of y equals 0. Thank you for checking out my videos. Have a great day.